Okay, ladies and gentlemen, this is the last new thing we are learning. Solving linear inequalities. Now, you did see some of these last year, and it might come back to you, but there's a couple nuances and new tricks that we need to add to our belt. So, a linear inequality is a statement that includes one of these symbols. So, we've got equations and inequalities. They're very, very similar. However, an equation only has one solution, and an inequality has many solutions. There's just a limit to where they stop. The way we solve equations and inequalities is also very similar. We go backwards through PEMDAS. The only difference is in inequalities if, let me write neater here, if you multiply or divide, by a negative number, flip the inequality. Okay, now we're going to do a lot of examples. We're going to start with graphing them, and we'll move on from there. So graphing solutions to linear inequalities. First of all, you need to make sure you use a number line. Now, if I were to be graphing x is less than or equal to 7, my guess is that you have learned in the past that you've got the number 7 and you want to graph things less than, which would be towards the left. And so maybe you shade that space or you draw an arrow in that space. And then you also need a dot at 7. And because it says equal, you would shade in that dot, right? Same thing. If you were to graph x is greater than -4, you draw your number line. You've got -4, -5, -3. You would put a circle at -4 and you're shading where it's greater or drawing an arrow where it's greater. You don't fill in the dot because it's not equal to. Now, your My Math Lab uses parentheses and brackets for this information. So the only difference is instead of shading in a circle, they put a bracket. And instead of leaving an open circle, they put a parentheses. Okay? So the bracket includes 7. The parentheses does not include -4. And I'll keep those reminders for you. Either way, on quizzes and tests, I will accept. You can do either method on quizzes and tests. It's My Math Lab that you will have to use this method. All right. So let's do some practice with that. We're going to graph, and then we're going to do something new. The new thing you're learning here is interval notation. All right, so let's do some graphs. We've got x is greater than or equal to -1. So I've got -1, put a couple other numbers on my number line, and then because it says equal to, I'm going to use a bracket, and I'm going to where it's greater. So a bracket at -1 and shading where x is greater. Okay, so that's the graph. That's easy enough. Interval notation. I've got a little cheat sheet down here for you. Interval notation is going to be using either brackets or parentheses and the infinity sign. So what we can see is we've got a bracket on the left side, and we're going from -1 to infinity. And there's always going to be a parentheses on the infinity side. Never a bracket on the infinity side. Okay? Let's try another one. We've got x is less than 3. So I've got 3, 4, 2. Because it says less than, I'm going to use a parentheses. And less than is going in this direction, so I'm shading where it's less. Now, how would I write this in interval notation? So over here, I'm always going to read my graph from left to right. I'm starting at negative infinity, and I go all the way to 3. And I use a parentheses because there's a parentheses there. Okay? A little more challenging. This is called a compound inequality. So if I were to graph that, it says x is greater than negative 2, and x is less than 0. So it's between negative 2 and 0. It's not equal to, so I'm using parentheses, and I'm shading in between. To write that using interval notation, it's quite simple. It's from negative 2 to 0. Why don't you try the last one all by yourself? Click pause and try it on your own. I'm going to use a bracket because it could be equal to, and a parentheses because it's not, and shading everything in between. In interval notation, that's negative 1.5 to 3. We'll keep practicing this. All right, so now what I'd like to look at is actually solving inequalities. So remember what I said. We're going to go backwards through PEMDAS, and if I multiply or divide by a negative, I flip the inequality. So the first thing I'm going to do is add or subtract. That gives me 3x is greater than or equal to negative 3. Multiply or divide. I'm dividing both sides by a positive 3, so I'm not flipping the inequality, even though my answer is negative. It's what I do to both sides is what decides if I flip it. Now we need to graph that solution. We're at negative 1. It says x is greater than or equal to, so I need a bracket, and I'm shading where it's greater than. Okay, make sure it's very obvious where you're shading. Now I can write that in interval notation. Remember, I'm reading from left to right, so I'm going from negative 1 to infinity. Let's try another one. Why don't you click pause and try this one all by yourself? Okay, so the first thing we're going to do is distribute, just like in solving normal equations. Then I'm going to move all variables to one side. Then I'm going to add or subtract. Then I'm going to multiply or divide. And I never divided or multiplied by a negative. So I never flipped the inequality. Now, however, here, it can be complicated to read an inequality when the variable is not written first. So if I want to put the variable first, I need to make sure that the symbol is still facing the 7. You always want the symbol to stay facing what it was facing. So that can help me when I'm graphing. I'm going to have 7, 8, 6. It says x is less than or equal to, so I need a bracket and shading where it's less than. In interval notation, this would be negative infinity to 7. I bet you guys are doing okay with this. Not too bad, right? Let's do one final example. Let's see how challenging we can make it. Why don't you pause it and give it a try on your own? Okay, again, we're going to need to do distribute first. I'm going to draw a line down the middle because this is big and messy. I want to keep it straight. So I'm distributing the 7, and I'm distributing the negative 4. That gives me 7x minus 14 plus x is greater than negative 20 plus 4x minus 12. Ooh, lots of negatives here. If you get this right, you are a pro. Combine some like terms and simplify both sides. I got some more like terms over here. Remember, those are both negative. So that gives negative 32 plus 4x. Now I need to get all variables on the same side. I think I'm going to subtract 8x. Either or will be fine. You'll get the same answer. Remember that 14 is negative. That'll give me negative 4x there. Then I need to add 32 to both sides. This is why I chose to subtract 8x. I want a positive number there with that 32. So negative 14 plus 32, that's, let's see here, 16, I think? Let's double check it with a calculator. Oh, good thing I checked it with a calculator. It is actually 18. Negative 4x. Alright, so now I gotta divide both sides by negative 4. Ew, I'm getting a fraction. 18 divided by negative 4 is 9/2 simplified. So that gives me x, flip the inequality because I divided by a negative, and that's negative 9/2. I'm going to flip the inequality back because I'd like the x to be first. The symbol is facing x. And now to graph this. Yes, it's a fraction, but that's totally fine. Just write a fraction. Negative 9/2. What's bigger than negative 9/2? Well, you could write negative 8/2, which simplifies to negative 4. And what's smaller? Negative 5. Okay, so I don't have an equal sign, so I'm going to use a parentheses here. It says x is greater than. Okay, and in interval notation, that would be parentheses negative 9/2, comma, infinity and beyond. So why don't you guys give this some practice in My Math Lab? And I've got those reminders there for you, so you can have that up on your screen if you need it. I would recommend writing them in your notebook as well. You never know when I will let you use them on a quiz.